Hello there. I hope you're doing well. My name is Dennis Mande, and this time I'm here to talk about physics practicals both for O and A level. Yes, for O and A level, nowadays there is a harmony that was created, so the same concepts apply to the physics practicals of O level and even A level. So I've called this physics practicals, this kind of series. It will be about physics practicals. I will talk about a few concepts here in the laboratory. Others will be just theoretically discussed, sometimes just using screen recording to make life easy for us. So the 535/3 and 535/4, these are the two papers which are covered at O level. These two. This is physics practical paper 3, physics paper 3, then physics paper 4. Then for A level, it's it is P510/3. So that is physics paper 3 for A level. Now the format of this exam, both for O and A level, is that it covers basically 3 numbers. So 3 numbers are examined. Number 1, which is compulsory, comes from the widest branch, which is the mechanics, and it is compulsory for both O and A level. Then number 2 is either about light or heat. Most of the times it's about light, but even heat is also examinable. So make sure that you know both. And then number 3 comes from electricity or magnetism. Now, for the sake of the exams, just for the recent years, I think, for so many years, I think I've seen exams of A level and O level. They basically examine number 3 from electricity, but the syllabus specifies that we should have even magnetism understood. Now, the areas that you should pay close attention to if you are to excel in physics practicals are basically in 2 categories. Number 1 is the real practical that you do. The practical that you do in the laboratory. And basically you need to understand how to use measuring instruments. So you need to know how to use specific measuring instruments. How you should use them. If it's connecting them, for example, in electricity, if it's measuring to the required degree of accuracy, that is what contributes to the great performance that you need to have. So you ought to know how to use them and then how to record the results that you obtain, all the readings, to the best degree of accuracy. And always, unless specified, you should follow the degree of accuracy of the instrument that you are using. I will start with a few instruments here. Number 1 is what we call a meter rule. This is what we call a meter rule. A meter rule. It is 1 meter long. 1 meter long. This is 1 meter. 1 meter is 100 centimeters. So, a meter rule, and at the same time, even a half meter rule. This is just a half. Just a half. A half meter rule. So, I can combine 2 of these to make a meter rule. A meter rule and the half meter rule both are used for measuring length. And if you are recording here using a meter rule or a half meter rule, I will call this part A. So for part A, we are recording length. We use these 2 instruments, actually, which is the same instrument. We use for recording length in centimeters. That's the default, centimeters. If they have not specified, for example, in light, the distances measured using a meter rule should be in centimeters. So, length in centimeters to 1 dp, 1 decimal place. 1 decimal place. An example is you can measure and you get 20 centimeters. If you write 20 centimeters, it's wrong. It will be crossed. So you write 20.0 centimeters to emphasize the degree of accuracy. And we always tell people, if you are writing centimeters, don't write 20.0. Then you put a signature. Don't sign. Write properly. Write in an organized way. 20.0 centimeters. Understand that these are three significant figures. 1, 2, 3. We shall talk about those later in the second part. Now, in meters, if you are required to state your answers in meters, then in meters we record. We can also use a meter rule or a half meter rule to determine length or to measure length in meters, 2, 3 decimal places. An example is using this very one, 20.0 centimeters. If you convert to meters, you will get 0.2, you add 0 meters. Please write properly. You have to be very organized, very organized. Yeah, that's about a half meter rule and even a meter rule. Number 2 is what we call a stop clock. A stop clock. A stop clock. Now a stop clock is this device that you see here. This one here. This device does not use electricity. It doesn't use electricity, but it operates on Hooke's law. It's just a matter of putting some tension in. There is a mechanism that creates tension, and then that energy which is stored, that elastic potential energy, is what makes it operate for some time. Please don't tamper with this part unless you are in charge of experiments, if you're a technician. But for the students, your role is just to operate. This other side here is a, okay, you can see, I will talk about this later, but then to start, you take this part up so it starts moving. And then to stop, just bring it down. Now to reset it, this part, bring it down, then it goes back to the 0. Where you find 60, that 60 is where the 0 starts. So, like that. This is a stop clock. We will talk about it when we look at mechanics experiments in details. So for now, our interest is, what is the degree of accuracy? So this one, a stop clock, part B, this one measures time. It measures time in seconds. To how many decimal places? To 1 dp. Now, you measure your time in seconds to 1 dp, but understand that the last digit should be a 0 or a 5. The last digit should be 0 or 5, strictly that. An example is if you have used the stop clock to determine time, and you measure the time, and you obtain t equals to 9.6 seconds. That will be wrong. That will be wrong. So it will be crossed. I said the last digit has to be a 5 or a 0. So at least if you wrote 9.5 seconds, this we understand that you determine that. Or you can embed it right properly. T is not written like that. That's not a T in physics. That's a plus. T in physics is written, you cross through T like this. That is a T in physics. All right. Now, you can have 9.5, 10.0, but always 1 dp. An example, if someone gets 25 seconds, they write 25.0 seconds. A small s. Small s. Now, a stopwatch, unfortunately, I don't have one here where I am right now. Don't have one here, but I will be able to show you one. Maybe later on. A stopwatch is like a stop clock. For it is simpler to operate. Simpler. Stopwatch. Just the only difference is for it records time to 2 decimal places in seconds. So for part C, we are saying this records time 2 dps in seconds. And please understand that if you're writing seconds, we don't have the abbreviation of seconds as S.6. That's not true. That's not true. So you write, for stop clock, we measure time to 2 dps, the degree of accuracy is 2 decimal places, in seconds. In seconds. An example is, if you find that someone obtained the time of 31.82 seconds, that means they used a stopwatch. They used a stopwatch. Okay. And for it has no restrictions. You can write the last digit can be from 0 up to 9. Any of the 10 digits can operate. Then next, part D is what we call a protractor. We all know protractors. Part D is a protractor. This measures angles basically. It measures angles in degrees to 0 dps, whole numbers. So I have the chalkboard protractor one here. Yep, it's one. Now, you can use it for measuring angles. You have the small ones, so you can easily use those ones and you measure angles. I'm putting an example. You may have 30 degrees that can work. You can have 21 degrees. You may have any degrees, but you write them as whole numbers. Next, we have an ammeter. An ammeter. By the way, before I cross over, just assume I have a line here and another line here. And I would like to measure the angle theta between them. What you do is press your protractor. Press your protractor. If this is a protractor, make sure that there is that line that passes through 0 and 180. And then there is a reference point. For your protractor, there is a line here and a line where the two intersect. It must be here. And then, so it means that this one here, the line of 180, this one here, 180 through 0 is here, and then I measure my angles. So I have here 10, 20, 30, 40, 45, 46. I have 46. So this is 46 degrees, like that. Degrees. An ammeter is used for measuring current. If you do electricity, an ammeter. So we have an ammeter. I'll talk about the details of this when we are looking at electricity. Yes, but this is used for measuring current. It measures current. To how many decimal places? So part E, this measures current. We write it as I, current I. 2 dps. 2 dps. What is so special is that the least count is 0.02 for like such an ammeter, and therefore the values obtained here should be even values. Even values. An example is you can have maybe current I equals to, let me say 0.24 amperes. That will be right. If you measure and for you obtained 0.25 amperes, that will be very wrong, because the question will be, how did you get that? Most of the ammeters that we use are always these ones here. The ammeters that we use, their least count, the value of one division is 0.02. So this multiplied by any number of divisions will always give you an even value. Please observe that all ammeters should have their readings recorded as even values. Then voltimeters, an example is one here. This is a voltimeter. There is a V. How do you differentiate between an ammeter and a voltimeter? You realize that for an ammeter, there is an A for an ammeter, and then for a voltimeter, there is a V. So that's how you differentiate them. How to connect them, that is some other lesson altogether. How to read them in details, also another lesson altogether. So we are saying that a voltimeter, it measures, this measures voltage to two decimal places. And what's so special is that the last digit should be 0 or 5. A 0 or a 5. An example is you can have, the reason is because the least count is 0.05 for most of the voltimeters that are given in the confidentials of the enable exams that you do. So if you get 0.05 times any digit, you will get any number of divisions, you will get either the last digit as being a 5 or a 0, but to two decimal places. A thermometer, now a thermometer, the unfortunate bit of it is I still don't have it here, but during the time of the experiments for heat, I'll look at it in details. The degree of accuracy is 1 dp. You write 1 dp, 1 dp. Yeah, previously they used to say whole numbers, but then for the sake of accuracy, when there are changes, they say 1 dp, and the last digit has to be a 5 or a 0. So it is treated, the thermometer, this one here, is treated just like a stop clock. Treated like a stop clock. You have just to have that at the back of your mind. Now lastly, for our introductory lesson today, I want you to know that most of the marks, even rub here properly, most of the marks in physics practicals, they come from knowing how to present and manipulate the results obtained. So the second phase, after knowing how to use the instruments, then you must know the presentation and manipulation of the results obtained. Under presentation and manipulation, you need to know basically the single measurements, then how to deal with the table of results, graph work, and the calculations. I am going to talk about these one by one, but in just short, I think just briefly, for O level, things are a little so basic. It's at A level where you will have a lot more to do with the single measurements. Yeah, that's the introductory bit of it. Maybe one more thing. Please ensure that you write properly. Appropriate letters should be used. Capital A has to be a capital A. Write the capital A properly. Don't write capital A like that. Please, this is not fine art. You write properly. A, small a is that, and capital A is this. Capital B is this, small b is like. Please, you write properly. Capital C, small c. A D, not. You write properly. Common common letters which disturb students when they are writing in UNEB and they end up doing their own experiments is when someone is asked to write maybe like an X. Record the X. You see what I've written? This is what they write. X equals to 21.8 centimeters. What is this? What is this? Those are two C's. Those are two C's dancing back to back and face to face. You see? So you have to make sure that you write small x like this, or else write small x like this. How do we know that it is small and it's not a capital X? We compare with the neighboring small letters. Yes. So this is correct. This is also correct. Y, capital Y, can be written like this. Capital Y can be written like this. Small y is this. Yes? Please, when you're writing, don't write kangaroo letters. This is wrong. And there are those who write and then they try to decorate. There are those who write Y. Hello? No. That's not allowed. Write appropriate letters because they represent variables. And then the other one is the T. Someone writes T. T. Capital T. T in seconds. They're writing period. This is not T. Write T properly. Capital T, write it properly. In seconds. This is a small s. So you can easily handle that. You can easily handle that. Small t is not written like this, please. Not written. It's not written like this. That's not small t. If someone says t in seconds, no. It is t like that in seconds. Write properly. Even the other capital T which is common is this. T in seconds. I'm like, seriously? You people. Because maybe for you in history, when you are talking about the contributions of the Arabs to the economic development of East Africa, you said, they write this. Which letter is this? Which letter is this? For us in physics, we have no mercy. This one, we shall slay you. So please write appropriate letters. Appropriate letters. And if there is any challenge, please feel free to drop a comment so I can know what to talk about. But I'm going to talk about physics practicals phase by phase to cater both for O level and A level. Remember that there was a harmony created for all. There was a harmony created for all. And on the other hand, I want to encourage people. I have a very nice, not just me alone, but we are a group of around 6 or 7 teachers. We put together a very standard and up-to-date practical guide, a very nice one. It has everything that a child needs, enough exercises, enough examples, and it will help you excel. For those of you who are at O level, please, you can, the teachers kindly get in touch with me, can help you process and get one cheaply. Yeah, you can get one cheaply, and we shall see how we can coordinate. Thank you very much. I sign out for now. See you in the next lesson. Bye-bye.